2, and welcome to lesson 6.5.1, so part 1. How do you factor higher order polynomials? So we are going to be learning some newer stuff here, and really it's just a combination of all of your factoring skills for higher order. So these are things like x to the third, x to the fourth, and we may even see some x to the fifths and higher exponents coming up here. Really, it's not too bad. The first methods here, and it's always a great idea to always check for a greatest common factor first. So for number 1, if you notice, every term has a common factor of x. What we can do is take that factor out, okay? Just remove that common factor. That would leave you with x squared minus 5x plus 6 equals 0. So the first step, remove the greatest common factor. From here, our other factoring skills come back into play. So hopefully you remember how to factor things like a positive 6 that add to a negative 5. Factors of positive 6 that add to negative 5 would have to be negative 3 and negative 2. Negative 3 times negative 2 is positive 6. Meaning that our solutions or our factors are x, x minus 3, and x minus 2. Now that we're set equal to 0, you also have to remember we are solving. So when you're solving, this part is factoring, okay, everything we just did. Solving, you just split every part up, so we have 3 parts, and we set each equal to 0. So over here is an x equals 0. It's nice and easy. X minus 3, where that's equal to 0, well, that's just if you add 3 over, you get x equals 3. And where x minus 2 equals 0, that's just x equals 2. So 3 answers. 1, 2, 3. GCF first, and then factor old school. Number 2, so they all again share that x. So we'll remove that first. That's going to leave us with x squared minus x minus 20 equals 0. Remember, so negative 5 and positive 4 would be our factors to get us to negative 20, making it x and x minus 5, then x plus 4 equals 0. Don't forget, cut it all up to solve. So 0, 5, and negative 4. And again, that is by setting each of these equal to 0, each factor. So third power, 3 solutions. Pretty cool stuff. Okay, next on up is factoring, and also our little hint here is check for difference of squares. Remember, difference of squares, that's a square factor. If you have something like x squared minus 16, you can rewrite that as x minus 4 and x plus 4. But let's figure out this first thing here. So this first time around, we see something x to the fourth. Now we've done that before, and we factored by grouping. Here we just have 3 terms. So instead of just x and x, we're just going to think factors of x to the fourth are x squared and x squared. And we're still looking for factors of 6 that add to negative 1. Factors of 6 add to negative 1, negative 6, are negative 6 and positive 1. So now, the only thing that's different is we're going to write our factors as x squared plus 1 and x squared minus 6, and equals 0. From here, so once you have that split up, we don't have a difference of squares. This is a sum of squares. That's not the same thing. We can split each into 2 and still solve. Now, we dealt with square roots last chapter. So here we have x squared equals negative 1 if you subtract 1 from each side. And over here we have x squared equals 6. Remember, you can square root each side. So x is equal to plus or minus the root of negative 1. Who remembers what the square root of negative 1 is? I'll let you think, I'll let you think. That's an I, so plus or minus I, all this stuff coming back And over here, we have the square root, so x is equal to plus or minus the root of 6. Okay? Don't forget plus or minus when you're square rooting. Okay? Big things, plus or minus when square root. Okay? Maybe star that for yourself. All right? The next one, so x to the fourth with 3 terms. Just think of it as x squared and x squared. Factors of 8 that add to negative 2, negative 4 and positive 2. So we have the factors x squared minus 4 and x squared plus 2, and those are equal to 0. Here is our difference of square piece. Okay, difference of squares right there means we could just rewrite this as x minus 2 and x plus 2, and then we have that x squared plus 2 equals 0. This point, we have different things to chop up. X equals positive 2, if we set that equal to 0. Setting the middle one equal to 0, x equals negative 2. And the last one, x squared plus 2 equals 0, means that x squared is negative 2, which the square root of negative 2 plus or minus corresponds to x equals plus or minus I roots of 2. So rather involved with our answers, but it's just a big old combination of everything we've done. So the last few units were a little easier. Here we're getting a little more challenging. Okay, so factors with imaginaries into the 4th power. Sum and difference of cubes. Here I have 2 gifts for you, and they are formulas. So the first is a sum of cubes. If you have an a to the third plus a b to the third, if you have perfect cubes, you can rewrite that as a plus b quantity a squared minus ab plus b squared. If you have a difference of perfect cubes, then it's a minus b a squared plus ab and plus b squared. Hang on to these. You can use them as you factor. I'd say memorize them, but you can really use your notes and such, so it's just a great little trick for you. Sum and difference of cubes. Now, if you don't know your perfect cubes, they are things like 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, I believe, and so on. So these are your perfect cubes I'm talking about. So this first one, we have a sum of perfect cubes. So following that, we can use the sum of perfect cubes equation. What we are concerned with is what is the cubic root of 64, and that is 4. So 4 to the third is 64. That's what we're going to put in for b. The cubic root of x to the third is just x. So that's what we're going to put in for a. And once you recognize those, you just substitute right into the second part. So we have a plus b, okay, which in our case is x plus 4, a squared, or x squared, minus ab, so minus x times 4, or 4x. It doesn't really matter the order. You can switch them. And then plus b squared, or plus 4 squared. Now, please simplify that. So x plus 4, x squared minus 4x, and plus 16. Okay? And that is what it factors out to be. So just be careful. The second part, simplifying the 4 squared into the 16, is really the key thing there. Next up is a difference of cubes. So 1 is a perfect cube. It's often forgotten about. That means our a value is cubic root of x squared, x third, which is x. B is just 1, and now we're going to use the difference. So we have a minus b, or x minus 1, quantity a squared, or x squared, plus, so the signs are opposite, 1x, or just x, and then plus b squared, or plus 1 squared, which is really just 1. So that is your final factored answer for sum and difference of cubes. Okay, so some new stuff there, especially with the sum and difference of cubes. Maybe let's just do one more bonus one for you. So 7, let's do something like 8x to the third minus 27. So these are two perfect cubes. A difference, so we're using the second function or formula. The cubic root of 8x to the third, okay, is 2x. So that's what you're going to use for a. Cubic root of 27 is 3. That's what you use for b. So 2x minus 3, or b. The first one squared, so a squared. Now be careful, that's 2x squared plus a times b, which is 2x times 3, and then plus b squared, or plus 3 squared. As you simplify this, it's 2x minus 3 times 4x squared. Remember, you can distribute that too in this case. Plus 6x plus 9, and that is what it comes out to be. So thank you guys for watching. Practice those. They do take a good bit of practice. Go back through, watch a little slower if need be. Great job.